Good morning, students. Today I am here with class 12th, lecture 2, homework solution, chapter number 5. As you all know very well that there were 5 questions given in homework. So let us discuss the solution of those questions which were given in your homework. Let us start with the first question, which is question number 15. In this question, they're asking you to find the continuity or discuss the continuity of the function f, where f is defined by f of x, the values of x, and the function corresponding to those values of x is given. So let us form the number of cases first. In case 1, we will check when x is less than -1. In case 2, as you can see, we will check when x is equal to -1. The next case that we will take, case 3rd, will be when x is lying between -1 and 1. Right. Next case that we will take is when x equals 1. And the last case, which is case number 5, will be when x is greater than 1. So these are the 5 cases on which you are going to discuss the continuity of the function. Now, case 1. As you can see in case 1, case 1 is what? X less than -1. For x less than -1, for all the values of x which are less than -1, the function is a constant number. The function is -2. So, being a constant function, it is continuous everywhere. Right? At every point which is less than -1, you're going to get the answer is -2. Correct? There will be no hole in the graph. You're going to get a constant value. So it is a continuous function. So you just can write, being a constant function, it is continuous. Being a constant function, it is continuous. Clear? Okay. Now, in case 2, as we can see, x equals -1. So what we have to prove for continuity, f of -1, its LHL and RHL should be equal. These are the 3 things that we need to prove them equal. So first of all, f of -1 we will calculate. When f of -1, that means x equals -1. So you see equal to sign is here. So the case is -2. The value of the function is -2. Now let us do its LHL. In LHL, you will write limit x tending to -1 minus, that means values which are less than -1, in the neighborhood of -1. So the function will be taken as -2. So when you change into h also, the answer will remain as -2 because it is a constant function. When you solve your RHL for this case, you will write that limit x tends to -1 plus, that means a value which is greater than -1 but in the neighborhood, a very close value to -1. So when x is greater than -1, see the function is 2x. Correct? Changing it to limit h tending to 0, instead of x what we will write? 1 plus h. Putting the value of h is equal to 0, what is the answer that we are getting? The answer we will get is 2. Correct? So you see, is the function continuous? Your value of function f of -2 and LHL are equal, but they're not equal to your RHL. Hence, 1 point we got for discontinuity, that the function is discontinuous at -1. For values which are less than -1, we have seen that it is continuous, but when it is equal to -1, it is not a continuous function. Let us do the third case now. In the third case, as you can see, x is lying between -1 and 1. So I'll just take a different sheet. We'll write case number 3rd. When x lies between -1 and 1. What is f of x when x lies between -1 and 1? As you can see, when x lies between -1 and 1, the function value is 2x. It is same. Correct? So function value is 2x, and as we know this is a polynomial function, hence it will be continuous at all the values that are lying between -1 and 1. So you can directly write a statement, being a polynomial function, it is a continuous function. Now case number 4. Okay, in case number 4, let us go. Case number 4 is what? When x equals 1. So when x is equal to 1, we have to check whether f of 1, LHL and RHL, these three things are equal. So first of all, let us find out f of 1. Let us go to the original question. See, f of 1, when your x is 1, the function is 2x. So we will write it as 2x here, correct? So 2 into 1, it will be 2. Now we will check for LHL. Limit, I'm mentioning here LHL, limit x tending to 1 minus. For less than 1, let us check the function. As you can see, for less than 1, the function is 2x only. Change the limit to h tending to 0. Instead of x, you will write 1 minus h. Solving this, the answer will be 2 only. Let us solve RHL now. In RHL, we will write what? This is for case 4, fine. Limit x tending to 1 plus. For greater than 1, let us see what was the function for greater than 1. It is 2. So it is 2. The answer will be 2 only. So as we can see, the value of the function at 1, at less than 1 and greater than 1, that means 1 plus a value which is just greater than 1 in the neighborhood of it. So we see the function is a continuous function at 1. Now the last case, which is case number 5, we are going to solve that. In case number 5, let us see what was case 5. Case 5 was when x is greater than 1. And you see, for x greater than 1, the function value is 2 only, which is a constant number. So we will write x greater than 1, the function is equal to 2. Right? For all the values which are greater than 1, we are going to get the answer as 2. So the function is a constant function and is continuous. Hence, the function is continuous everywhere except which point? Except point -1, where we were not getting our LHL equal to RHL. This is how we discuss the continuity of the function. So this was question number 16. Same way you are going to do 15th question also, which was given in your homework. Let us now proceed to the next question. Here comes question number 20. In question number 20, they are asking you that is the function defined by f of x, x square minus sin x plus 5 is continuous as x equals 5. There are two ways to do it. One that I can tell you is, see, x square is what? A polynomial function, so it will be continuous. Sin x is continuous everywhere. 5 being a constant number, right, is continuous. So we are having algebra of these functions f of x, g of x, h of x, hence it is a continuous function. Another method that we have been doing in another questions is, first of all, you will find f of pi. F of pi, let us put pi in the function, we will get pi square minus sin pi plus 5. So we know sin pi is 0, we will get the answer as pi square plus 5. Let us solve its LHL, where limit x tending to pi. Now you know, for pi we have been given only one function. There are no two different functions. So we definitely know that one function is to be operated and it is going to give us the same answer. So LHL and RHL is not mandatory to be shown, but it is good if you show. That gives the clarity. So limit x tending to pi, the function is x square minus sin x plus 5. So when you solve it, as you know, there is no 0 by 0 form, we can put the limit directly also. Otherwise, the proper way to write is h tending to 0. Instead of x, what will you write? Pi minus h whole square minus sine of pi minus h plus 5. So when you put h as equal to 0, what do you get? You get pi square minus sine pi, which is 0, plus 5. So the answer that you get is pi square plus 5. Similarly, in RHL, when you solve, instead of minus h, you will have plus h. That's the only difference. So let us do x tending to pi plus, write the function. Clear? Now when you change it to limit h tending to 0, what do you get? You will get pi plus h whole square sine of pi plus h plus 5. Putting h as equal to 0, you get the answer as pi square plus 5. Now you see LHL, RHL and function value at that particular point is equal. Hence the function is a continuous function. That's all is to be done in the question. So I hope this is clear. We can move to the next question now. Here comes the next question, question number 21. 21 question has other parts also. I'm going to discuss just one part where f of x is given as sin x and cos x. Okay, one thing to keep in mind, these are some of the theorems whose proof you need to remember, that if f is a function and g is a function, if f and g both are continuous, then their addition, their subtraction, their product, their division, correct, all are continuous. Clear? So let us see sin x. Sin x is a continuous function because in the graph of sine we find values at each and every value of the angle. We don't have any value of angle x where we find the sine function as not defined, right? So sine being a continuous function, cos x is also a continuous function. At each and every angle we have a definite value for cos x. So the summation of two continuous point is a continuous. But if it comes for separate, it comes separately to prove sin x and cos x. I'll tell you how to do it. Suppose you consider g of x as sin x. So we will take any real number c, okay, or we may write any number c that belongs to capital R. Clear? So c is a number that is that is belonging to capital R. So just to see now, g of c will be sin c. Okay, suppose you do the LHL part. Limit x tending to c minus sin x. So what will you write? Limit h tending to 0 sine of c minus h. Correct. So when you write c minus h, put h as equal to 0, you get sin c only. Similarly, when you write c plus h, again putting h as equal to 0 in RHL, what will you get? Sin c. So you see sine is a continuous function at any value that belongs to real numbers. Similarly, you can prove for cos and then say if both are continuous, their addition and subtraction is also continuous. This is known as algebra of continuous functions. Let us go to the last question of the homework which was given to you. Here comes last question, which is question number 23. Okay, in this function they're asking you have to discuss the points of discontinuity or find the points of discontinuity of this function. F of x is this given. So we will check at x less than 0, then x equals to 0, and then all the values which are greater than 0. So for x less than 0, the function is sin x upon x. Now sin x is continuous. X is also a continuous function when it is less than 0. Hence, the division of two continuous function is a continuous function. This is all you need to do in this part. In second case, at x equals 0, you will find f of 0. Now you see at 0, what do you have? X plus 1. That means 0 plus 1, which is 1. Then you will find LHL and RHL. In LHL, you will take the function as sin x upon x. Okay, at 0 minus x tending to 0 minus, and limit x tending to 0 plus, the function will be x plus 1. So you will be solving these both and deciding whether this is continuous or not. Similarly, for greater than 0, fine, you will check whether the function for greater than 0, the function is x plus 1 only. Being a polynomial function, it is a continuous function. So the only thing to be done here is in the case number 2 where x is 0, you're going to find LHL and RHL separately and just to see whether they are continuous or not. For more clarity, let me give a solution for the second case where what we are doing is taking case 2 when x is 0. So f of 0 was coming as x plus 1, that means 0 plus 1, which is 1. LHL, and here I will solve RHL. In LHL we have a limit x tending to 0 minus, we have the function as sin x upon x, and here limit x tending to 0 plus, we have the function as x plus 1. You can see here in the question. Yes? Okay. Just see now. Limit h tending to 0. Instead of x, you're going to write 0 minus h and 0 minus h here. So you will get minus sin h upon minus h. Minus minus getting cancelled. Limit h tending to 0. Sin h upon h is the formula where the limit is 1. Here in this case, when you put as 0 plus, so limit h tending to 0, 0 plus h plus 1. Putting h as equal to 0, we get the answer as 1. So you see, all three of them are 1. So there is no point of discontinuity for this function. This function is a continuous function. So in the next lecture, I'll give you some more solution of the exercise questions. So this is for this lecture only. Thank you all.